Here's where we're going to get into kind of I want to say the workshop component of this, but unfortunately I was told not everybody had laptops with them. What I wanted to do was break you into groups and do design challenges and have you come up with 3D models, but we don't have enough time for that. It's only an hour and a half and you guys don't have computers, so we can't do CAD. So we're going to do something slightly different, which is I'm going to talk about some of the things that I've seen changing in the world of 3D design, and then I just want to open it up to brainstorm. What do you guys think 3D printing could be used for to disrupt in the world? Metals, plastics, ceramics, biomaterials. I'm mostly focused on metals and plastics. That's where my interest is. I'm a mechanical engineer. I like things that are actually useful. Yeah, exactly. Strong. So this is probably one of the most mundane but coolest applications of 3D printing that I've seen. I've got on the left market size, and that just gives you a sense of how valuable of a problem this is to actually solve. But on the right, it gives you a little visual depiction. So in conventional milling, you have an end mill that spins really fast and cuts metal or plastic, whatever it is. They typically have, on high-end CNCs, they have channels to push coolant through. And they use this coolant to cool down the tool, because according to the Taylor tool life equation, the heat transfer rate to your tool will ultimately cause your tool to break. And with coolant, it helps get that heat out so that the tool doesn't break. The value here of making a tool last longer by getting more coolant through it is the tool will last longer. And having a tool that lasts longer means your machine, you're not consuming as many tools, which costs less money, but the real impact is that your machines don't ever go idle. You're always able to use your machine to continue to create value and cut more material. And that's very, very important for a manufacturer, because at the end of the day, when I own a piece of capital equipment, if I'm a finance guy working at a manufacturing company, every minute that sits there operating is making money, and every minute that it's sitting there not operating, it's losing money. There's no neutral state. It's either making money or losing you money. And when you have a broken tool, you're losing money. And the value here is, what's really cool is they redesigned the channel, the angle of the channel, and the orientation of the channel. Instead of being straight, they curved it. And as a result, they were able to increase the coolant flow by 100%. Which is, I don't want to say it's a one-to-one, the tool doesn't last twice as long, but now the tool lasts longer. And that means that the machine can create more valuable parts for a longer period of time between the tool changeover. That's really important for the manufacturer. Here's another example in automotive. Nobody's done this yet today. I think this is a direction the world is going to head. So the last one is something somebody's done. This one, nobody's done yet. The chassis of a car is typically an extrusion that gets welded together, and it's a very basic box shape. It kind of looks like the shape of my hands. Imagine instead, kind of mimicking nature a little bit, what if you could take a bridge design and make that go inside of the chassis? What if you could print trusses inside of the chassis? What if that extrusion was a nestled group of trusses, kind of like a tessellated shape? That would allow you to increase the strength to weight ratio, but simultaneously remove material from it. So you could have a stronger object that weighed less. What would that do to the automotive industry? It reduces the weight of your car. Your car is now more fuel efficient. It consumes less fuel. You have a more marketable product to sell. Or you have a higher performance vehicle. Your torque to pounds ratio goes up.